Good evening or good morning, I'm not sure. It's a real pleasure being back and seeing so many faces, both new and old. So I'll be chairing today's last session, and there are 3 speakers. Each will have 30 minutes for their talk in the Q&A. So ideally the talk would be 20 minutes, so we have 10 minutes for Q&A. But of course you can shift a little bit. What I suggest is that everyone who has questions, feel free to already formulate them into the chat, which you can find at the bottom of your screen in the middle, and just press enter. That way, after the talk, we can go through the different questions. So without further ado, I guess I can introduce the first speaker of today, which is Gabriela García Zerecero. Is it correct?
Yes.
Who will give us a talk on the unitary and substantial character of molecular systems. So Gabriela, the virtual floor is yours.
Thank you so much. Well, as Peter has already said, this talk is about the unitary and substantial character of molecular systems, and it would be a reflection from Bertalanffy's general system theory. Okay. So the problem of complexity of reality has become one of the main challenges for both scientific and philosophical knowledge from the beginning of the second half of the 20th century. To understand this complexity, we are currently talking about systems. From this perspective, it may be interesting to question whether molecules and macromolecules can be considered material systems, that is, if they have a particular holistic character. Given that systemic approaches have been developed lately in chemistry, I intend to show through the general system theory that molecules and molecules can be considered central unitary systems, which allow us to recognize its character as a whole and therefore be able to establish its substantial identity. The 20th century experienced a deep questioning about the deterministic and linear approach from which natural sciences have managed to explain many aspects of material reality. The technical progress behind the material world transformation is proof of this success. Advances in science have gradually helped to forge increasingly complex intelligibility very superior to what ordinary knowledge allows us to verify. General system theory represents a broad point of view that transcends technological problems and therefore is useful in the attempt to understand this complexity. The main goal of this work is to show that molecules and macromolecules have a particular holistic character, one of the fundamental properties that defines an entity as a central unitary system. After describing general system theory fundamental properties, I will verify if its applicability to molecular systems. If the fundamental characteristics of a molecular system coincide with those of the traditional philosophical concept or long hold, then the central unitary system notion can be compared to that of metaphysical substantial unit. General system theory was proposed in 1928 by von Bertalanffy, a German biologist. Taking into account the predominant mechanistic approach, the biological research goal was to discover organizing principles at all levels. The idea of a system becomes from biology. General system theory emerged as a tool that could be shared by many different sciences. In a broad sense, it's presented as a systematic and scientific way of approaching and representing reality. It is characterized by its holistic and integrative perspective, based on the interrelations between the elements that compound systems. General system theory represents a new paradigm in scientific thought, a reorientation of thought and worldview in contrast to the analytical, mechanistic, and one-way causal paradigm of classical science. In short, a new philosophy of nature. From the beginning, general system theory has led to philosophical nature reflections that attempt to formulate the general problems posed by the relationships between order, irreducibility, and complexity of what is real. The foundation of general system theory seems to be the idea of a meta-science that proposes a total explanation of reality, a kind of ultimate explanation that particular sciences cannot provide. Bertalanffy claims for the general system theory this ability to formulate a meta-scientific explanation because of its unifying character. Would general system theory seek the ultimate principles of the different aspects of reality studied by science? Is it possible to propose fundamental principles for all reality considered as a whole from a particular point of view and not as such realities? The idea of developing a proper philosophy does not seem to have been clearly outlined by Bertalanffy, who fluctuates between an ideal of precise mathematical formalization as a definitive solution to replace philosophy and an universal aperture based on more general principles. Bertalanffy intends to make the totality intelligible, that is, to formulate valid principles that can explain systems of various orders, organizational problems, dynamic interactions that are not comprehensible by investigating the respective isolated parts. Is it possible to ask what is basically a system? Can we find in the concept of a system understood as an organization, as a totality, the elements of intelligibility that allow a more philosophical way of interpreting material reality? To answer this question, it's necessary to evaluate the philosophical scope of the fundamental characteristics that define a natural system. A system is an interrelation of elements that constitute an entity or global unit. A system can also be defined as a set of units in mutual interrelation. A system is a resulting unit of mutually related parts. It is a whole alone that functions as a whole due to its constitutive elements. A system is an organized totality made of related elements that can only be defined in function of their place in that totality. As we can see, these are different definitions of systems. From all of this, the latter is a well-articulated definition, since it considers the concept of organization in relation to that of totality and interrelation. There is in a system a set of interrelated units in such a way that the behavior of each part depends on the state of the others, since they are all in a structure that interconnects them. As a result, new characteristics and new properties emerge that did not exist in the previous components. Whereas in the relative recent past, science once concerned reducing phenomena to interaction between the elemental parts, today the emphasis is placed on the notions of totality, hierarchy, and finality, on relationships that arise in the totality and that they are not manifest in the behavior of parts, in the emergent properties, in the importance of structures of the organization. This suggests the existence of models, general principles, and laws that apply to all systems regardless of the nature of the entities that constitute them, the nature of the forces that interact, and the type of established relationships. Now, which are these system fundamental characteristics? The first one is the structural dimension. Holmes highlights the importance of structures as they express the systemic, holistic, and synthetic character of the objects. For the general system theory, the system has a greater degree of structuring and complexity than that of its parts. It has properties that are irreducible to those of the components. This fact must be attributed to the presence of the relationships that join them. Chemists talk about bonds or interactions, about interrelations. The structure notion suggests a hierarchical arrangement of elements. The unity of the idea of the structure suggests an organized unit that contains the constituent elements and the relationships between them. The structure notion considers multiple elements and their relationships. However, the unity is assigned to the whole. The structure notion is fundamental because it allows us to glimpse the hierarchical notion. The model characterization of natural entities gives special relevance to dynamism that extends to all levels, from biological to the physical, chemical, and the microphysical, forming in each one of them systems that have structural complexity. Dynamism contains information that is stored in special structures that in turn are the source of new types of dynamism. Structuring thus becomes a fundamental characteristic for scientific progress and seeks a broader and deeper knowledge of natural structures. The second characteristic is that of organization. What does organization mean? In a first approximation, organization is the relationship between components or individuals that produces a complex unity or system, endowed with unknown qualities at the components or individual level. Then this notion attempts to express what the structure notion cannot explain in terms of the dynamic nature of the material system unity. And although there is a certain circularity between the terms of interrelation, organization, and system, they are relatively distinguishable. The idea of interrelation refers to the union modes and forms between elements or individuals and between these and the whole. The idea of system refers to the phenomenological characteristics and properties of the related whole and its complex unity. Finally, the organization notion refers to the arrangement of the parts within, in, and for a whole. Organization is the key concept that links the interrelation notion with the system notion. We could say that if the structure concept particularly expresses the order idea, a defined disposition idea, the concept of organization would indicate a permanent and integrated whole idea. The third characteristic are the emergent properties. General system theory affirms the existence of so-called emergent properties that are the system qualities presenting an originality characteristics related to qualities or properties of components considered separately with a different shape in another kind of system. There are not only additive properties that are the result or the effect of the simple aggregation of the respective properties of the initial components, but also new properties that are the result of the interactions between these components. These interactions would give rise to qualitatively different entitative levels that must be studied according to their own laws. It can then be established that at different natural levels, there are systems that cannot be reduced to a simple juxtaposition of the components. These systems already have properties that are not found in their components. There is a specific dynamism and structuring of such a system. The emergence notion is related to the irreducible character of the material systems studied by chemists and biochemists. The hydrogen molecule, for example, is a highly flammable lighter than air gas, while water at the same temperature and pressure is a liquid commonly used to extinguish fires. These properties change radically and have nothing to do with each other. We are facing a new reality. These water emergent properties compromise these molecule components. In water, there is no longer room for hydrogen, extremely flammable. Now, we are going to talk about directional dynamism. General system theory emphasizes that finality is a characteristic of organic wholes. Systems are the results of trends that show teleological behavior. General system theory underlines the functions of the parts in the whole and in relation to others, that is, the functional relationships that are characteristic of organized systems. Bertalanffy distinguishes different types of finality. First, the static teleology or adequacy, meaning that an arrangement seems useful for a certain purpose. Dynamic teleology, meaning an orientation of processes, in other words, the direction of them towards a final state that can be expressed as if the present behavior depends on the final states. And what he calls the movement that is based on structure, denoting that a structural arrangement derives the process in such a way that a determined result is achieved. Finally, Bertalanffy also proposed another type of finality, in which he considers that the same final result can be achieved from different initial conditions and by different means. This,
Gabriela,
yes.
Sorry to interrupt. You have 11 more minutes, including the Q&A.
Yes, thank you so much.
No problem.
I was saying that this last finality is which he considers the same, this is one that he considers, okay. Bertalanffy also proposed another type of finality in which he considers that the same final results can be achieved from different initial conditions and by different means. This type of movement can be found in open systems, systems that exchange energy and or matter without outside if they are reach a stable state. So what can we say about central unitary systems? Well, a system designates those entities to which characteristics indicated by general system theory can be applied, namely Holmes, structuring, organization, emergence, directionality. Unitary systems then have special unity in both dynamic and structural aspects. And central systems, they have in themselves a center that attracts the components towards unity, and because they play a central role due to the fact of dynamism and structuring, are articulated in them. Central systems have particular characteristics, both to their internal dimension and activity. They have their own dynamism that unfolds following defined guidelines, and their own potentialities and tendencies. There is certain functionalism and comparability between their parts and their components, perform functions that make the existence of the whole possible to contribute to their activity. So characteristics of a central unit system is individuality that refers to a certain degree of dependence that manifests itself in having its own dynamism and structure, and unity that refers to the effective integration of the components in a system, that is holism and cooperability. In central unitary systems, I have already said that nuclei, atoms, and molecules have a proper and unitary structure and dynamism that is different of aggregations. And although the structure of molecules is represented by chemical bonds that join atoms together, chemical systems are not explained by mere external interactions of their components, but have their own holistic and directional character. So central system notion can be applied, therefore, to both microphysical entities, atoms, molecules, and macromolecules, and to chemical substances formed by atoms that constitute an unitary and dynamic unity, and also to living beings. So, as I lack from time, I want to say that all these explanations, I want to arrive to these classical concepts that explain reality, because what I would like to present is that these concepts of formal material cause, formal cause, that we can refer to these behavioral systems lead us to the form concept that is not an operational concept similar to experimental science magnitude, but refers to the way of being of natural entities. Okay, so to conclude, I will mention in a brief way the main ideas. So, general system theory supports an ontological, holistic, emergentist, and structuralist vision that permits systemic study of natural entities. These dynamics converge in the production of unitary results. Molecules and macromolecules are the object of the study of chemistry and biochemistry, and are not complex materials where the components are simply located in relation to each other. Thanks to the explanation of certain fundamental concepts of molecular and macromolecular chemistry, it can be justified that chemical and biochemical entities constitute central unitary systems. So the holistic character of material systems in chemistry and biochemistry has an unitary explanation of a causal order that justifies their character as a whole. The way of being of the central systems corresponds to the concept of form. These systems are dynamism and structuring centers and have a unitary way of being with holistic characteristics that are not found in their components. So in the framework of general system theory, the concept of organization explains the stability of the molecular system. Emergent properties are new global properties, since they are the result of the transformation of atomic elements into parts of the molecular whole. So molecular systems show the central unitary system characteristics. However, these characteristics are not univocal in the sense that, for example, the dynamic structural centrality of a chemical species do not have an identical mode of being for the different types of organization. Thank you.
Thank you, Gabriela. We have 5 minutes left for Q&A, and there were already 2 questions in the chat. Guillermo was the first one to raise a question.
Okay, yeah. Thank you, Gabriela, and thank you, Peter. It's more than a question, it's a comment, and it's that that idea of that teleological behavior of systems could be framed in let's say more mathematical terms, and is that when you have a system that is evolving, then you have different events, and those events, depending on the decisions of the actors belonging to the system, some of those events maybe have some preferences. And then with the pass of the time, those events keep being repeated and repeated and repeated, then you have path dependencies. And with those path dependencies, you could say that that is something like the system is approaching to the final stage, something like a teleological fate or something like that. But that could be framed in statistical terms, and it has to do with of course, with the individuals of the system, but with the decisions they made and how they repeat those decisions. That has been, for example, shown in some events in chemistry. It was just a comment.
Yes, I would like to say that I got a little bit nervous because of the lack of time, but what I intended here is to show that the metaphysical or the philosophical view from these chemical natural kinds of molecules and molecules, because of Bertalanffy's general system theory, pretends to be a wide view which we can make from the specific scientific sciences. No, mathematics, physics, chemistry has a particular view. What Bertalanffy intends, and I'm not sure that he realizes, is to have a philosophical view that is an ultimate explanation of reality, but using sciences. So yes, this teleology has its characteristics because of the particular systems. But at the end, this central unitary system, it moves through, or it has this teleological behavior because it's central unity, because what I want to arrive is the concept of form, the classic concept of forms that explains why one teleology can be different from others. I don't know if I explain myself.
Yeah, thank you.
We have time for one quick last question. Jesus, I think you were the second one.
Hello. Because, I was wondering which is the relation with the Aristotelian hierarchism. According to the substances are matter in the form of the material parts of the whole, and the form is, as far as I know, is the principle of it. But in your case, I don't clear for me which is the principle of unity. If it is the structure or the interrelation parts or the organization. And yeah, that's my question.
Okay, I don't know if I understand well, because internet is a little bit it's failing. But as I already said, well, the center of the core to define a reality as a central unity system is actually the concept of form. What makes a thing to be that thing and other potentialities is the form notion. So that's why the philosophical view intends to find the ultimate explanation of each reality, because the systemic approach helped us to understand realities as a unity, not as independent parts. So we can explain its behavior because of this nuclear core, because this way of being that is the form of the substantial form of classic philosophers.
But for example, the substantial form determines the structure or the organization of the parts.
Yes.
In some sense?
Yes, because it's the main core that possibilities all the behavior of the realities. So each reality will behave because of its form. And yes.
Okay, thank you.
Thank you. I think we'll have to wrap up here, but if there are any more questions, feel free to put them in the chat so Gabriela can see them and answer them either via the chat or later on. So thank you once again.
Thank you so much.